Hello, welcome to this informative video on condensation and mold diagnosis. So I'm Paula López Arce, and I'm a research scientist at the Property Gate Association and an honorary research associate at University College London at the Institute of Environmental Design and Engineering. So from atmospheric moisture diagnostics project on residential buildings, we have developed an innovative method that we name BMI, Building Moisture Index, for the assessment of moisture imbalance and diagnosis of condensation, damp, and mold. So in this educational video, after a brief introduction, we will see what it is the BMI diagnosis method, which are the environmental parameters involved, which are the causal factors leading to surface condensation and mold growth. Then we will move to how to perform environmental monitoring, which is the basis of the method. We will see how the data is processed and assessed and how it is reported. And then we will see some case studies from data sets that are processed through the method of properties with and without mold, and some examples with details of the graphs generated and the values and results. And then we will explain which are the benefits of using this innovative BMI diagnosis method. So in the UK, there is approximately 1 million homes affected by any kind of damp problems. So building surveys are necessary to determine which is the type of damp that we are dealing with. So we can have rising damp or free liquid water ingress by capillary rise due to the lack or failure of a damp-proof course. We can have a penetrating damp from liquid water infiltration through runoffs or water leaks. And then we can have condensation damp from atmospheric moisture or water vapor production. So actually condensation and mold growth is one of the largest damp problems in the United Kingdom, with more than 500,000 properties affected by these issues. So UK homes affected by high humidities, low temperatures, and high occupancy densities are considered like having moisture imbalance environments due to the poor ventilation, irregular heating, poor thermal efficiency of the envelope, and obviously a high moisture production from day-to-day activities like showers, cooking, etc. And this can lead to surface condensation and mold growth, and eventually a lower indoor air quality of our living environments. So whereas there are diagnostic methods that have been developed for identifying rising damp, like the BRE Digest 245 and others, where the source is usually one cause with one straightforward solution, condensation damp, mold growth, the source is quite complex because it can be one or it can be the association of different problems and parameters that can have multiple solutions. That is why it is necessary to find accurate methods to identify the cause of the damp in order to take correct remedial actions and to achieve healthier moisture balance environments. So further investigation is necessary to perform the assessment of indoor atmospheric moisture and the assessment of balance-imbalance environment. Monitoring the environmental parameters of the environment may support the condensation damp diagnosis. But how moisture imbalance can be assessed in order to find the cause of condensation and mold? Well, the first step is environmental monitoring. So environmental data is gathered by sensors, data loggers, that record environmental parameters during extended periods of time, and they give detailed and representative information, whereas snapshots measurements by hygrometers or thermometers are influenced by sporadic events. However, there are some weak points from environmental monitoring. So there are no standardized guidelines on the type and number of loggers that are necessary to place in a property. And also there is no guidelines on the installation on the property, in order to have comparable results. Apart from that, a huge amount of data can be generated, so the process and evaluation can be time consuming. and also performed in a non-standard and quite subjective way. So that's why, and to solve those issues, an innovative method that we name BMI, Building Moisture Index, has been developed through several research projects in partnership of Property Care Association and University College London. So we have developed a diagnostic method, which is now a program, a code, that processes environmental data that is collected by sensors, and it performs the moisture imbalance assessment and determine the risk of surface condensation and mold growth in buildings. With this, we can identify which is the source of the problem of condensation and mold. But which are the environmental parameters that are involved in this diagnosis method? Well, the main raw parameters are air temperature and relative humidity, plus surface temperature measurements. So with this, we can inform on the risk of condensation and mold, and we can determine the origin of the problem, if it is the envelope, if it is the ventilation, or if it is the heating. And then from established parameters and thresholds published in the literature, BRICS standards, scientific publications, building regulations, we have a link of parameters. We have linked the parameters to assess the risk of surface condensation and mold growth in a standardized manner. So from those raw parameters that I mentioned, air temperature and relative humidity plus surface temperature, we can assess the thermal envelope performance, and we can calculate other parameters like the temperature factor to assess the risk of surface condensation. But what is the temperature factor? So this is the thermal resistance regarding the external and internal air temperature and regarding the internal surface temperature. So values close to 1, because this is an adimensional parameter, so no units, correspond to well-insulated structures, while lower values may take place in severe thermal breaches. Then, with those raw parameters again, we can calculate water activity in order to assess the risk of mold growth. So what is the water activity? It is the relative humidity at the surface in steady state conditions, and is calculated from saturation water vapor pressure and internal vapor pressure. So values below 0.6 or 60% RH correspond to no risk of mold growth, whereas values of 0.7 and between 0.7 and between 0.9 or 70 and 90% RH correspond to having a risk of mold growth. Then from those raw parameters, the air temperature and relative humidity, we can calculate vapor pressure excess in order to assess ventilation. And vapor pressure excess is the differential vapor pressure between the internal vapor pressure and the external one. So high values of vapor pressure excess comes from moisture production and inadequate ventilation. So values above 0.6 kilopascals correspond to trapped moisture from the accumulation of water vapor. And then from air relative humidity and temperature, we can assess the heating moisture regime. So high values of relative humidity and low temperature comes from moisture production and inadequate heating. As a reference, we have our comfort temperature and relative humidity zone between 18 and 24 degrees and 44 and 60% RH. And which are the causal factors that are leading to moisture imbalance and condensation and mold? So from water vapor production and the accumulation from day-to-day activities, plus the causal factors that I will mention as follows, they gives these moisture problems. The first causal factor is the poor building envelope performance as a whole or on thermal breaches, that is characterized by low temperature factors values and high water activity values. Second causal factor of moisture imbalance is insufficient or inefficient ventilation, and is characterized by high vapor pressure excess. And then a third causal factor is an inadequate heat moisture regime, which is characterized by low indoor air temperatures, can be because insufficient heating or heat loss, or infiltration of cold air. And then it's also characterized by high indoor air relative humidity levels. And then how can we proceed to get the moisture imbalance assessment? Well, the BMI system allows to monitor, to collect, process, assess, and report environmental data. And as I said, the first step is performing environmental monitoring. So we have some protocols, guidelines that explain how to program and how to install sensors in the property. So we are using commercial data loggers. It can be any kind that are able to register, to record, to gather air temperature and humidity and surface temperature measurements. And which is the basic kit of sensors that we need in a property in order to perform the assessment. So we need a first internal surface temperature, a second internal ambient air and temperature and humidity, and a third external ambient air temperature and relative humidity sensor. So the first internal surface temperature data logger, we will place this in the room with the largest damp mold issue onto the mold surface, or if there is no visual mold, we will place this on a thermal bridge. So we can use a thermal camera or a surface temperature meter to place the logger. Actually, it's better a thermal camera because we will have a better picture and to see if it's a whole affected area or are just some spots. So then we will place this logger on an indoor external wall. That is where usually these problems happen. And then we can use some strong duct tape to attach the thermocouples, the surface temperature loggers, especially if the surfaces are quite damp. Then the second internal ambient air temperature and humidity, we will place this logger in the same room than the surface temperature sensor, on indoor internal walls in this case, and on the middle of a top architrave door in order to find a standardized way of placing the sensors always in the same spots, but always away from sunlight and heating sources like radiators or electronic equipment. And then we can have additional sensors of this type in other rooms of the house, but this is the minimum kit of 3 sensors, with the third one, the external one, collecting the climate weather conditions, ambient air temperature and humidity. So this in this case has to be also away from heating sources, sunlight, and protected from rain and wind. So we have been using bird feeder cases, which are cheap and they can protect our external loggers. And then we will leave the sensors gathering the data a minimum of 2 weeks period, recording in intervals of 30 minutes. And how the BMI diagnosis methods process the data and how to perform the assessment. Well, the data loggers collect the environmental raw parameters, air temperature and humidity and surface temperature, which can be downloaded as Excel files and then uploaded into the BMI code program. Then a set of algorithms process the data and provides the calculated parameters that I've already explained: temperature factor, water activity, vapor pressure excess, which relate then to factors causing imbalance. And as I said, poor thermal envelope, poor heating regime, lack of ventilation that led to surface condensation and mold. And I have to remark that these are not based on average values. These are many ranges of data that are processed based on critical thresholds and weighted values that establish the metrics for the severity and likelihood of the event. So this is an example of the dashboard that is provided after all the calculations are processed. So we can have the impact extent of moisture imbalance created by each causal factor, which is given by a numerical indicator of no impact, that corresponds to 0, or extremely high impact to moisture imbalance, which is the value of 6. And then we have the total building moisture index, which is the combined impact of various factors that gives a total degree of moisture imbalance. In this case, that is very high, like 4.5, and we will explain some examples soon. So the data is generated through autonomous reports. So there is a set of results First, some explanations in the first and last page with also definitions and symbols. And then we have some pages of the report where we have some free space to introduce the property details and also free comments made by the surveyor. Have to remind that this is not a survey report, building survey report. It is an environmental report, which is complementary to the building survey. So here some comments can be introduced as part of the building survey, just for complementary information, as well as some pictures from the survey and that can be introduced in the program, and then they will be reproduced in the report. So regarding the results of the environmental assessment, we have this dashboard that I've already explained, and we will see now in detail with some short explanations about it. And we will see this in this first case of a property with no mold. Actually, this is a passive house with a mechanical ventilation with heat recovery and a heating system based in 95% solar panels. So here we have a very low moisture imbalance on this property of 1.3. And the influence of having a poor building envelope thermal performance causing moisture imbalance is very low. Then the influence of having an inadequate heat moisture regime causing moisture imbalance is also very low. The influence of having a low indoor temperature to moisture imbalance is very low. So we have warm air. The influence of having high indoor RH to the imbalance is also very low. So we have dry air. And finally, the contribution of having insufficient or inefficient ventilation is low. So we have a good ventilation. So in this same property, we can see the results from the graphs and from the average values that are also, this is a summary, and then we can see some tables with the data of the results. And we can see here the assessment of the thermal envelope performance of this same property in detail. So we can see that this is based from the data that falls in between temperature factor and water activity. So the impact score of temperature factor causing imbalance in this case is low, very low, whereas the impact score of water activity causing moisture imbalance in this property is also very low. So this is a summary, so we can see the same graph, but also we can see the text with that is considering the average values. So the temperature factor, 0.92, can be, even though it's an average, but as a whole, it can be considered as appropriate, and it is not a problem when in conjunction with water activity values, which as an average has the value of 0.41. Then we have our line graphs, which are taking in consideration the raw and calculated parameters, but no link in each other, as the BMI graphs do. So here some peaks can be observed, and the data can be reprocessed if we want to select a different range of dates, just to see some differences. And then here we have the assessment of ventilation, where we can see how the data falls in an area where vapor pressure excess is showing a low impact to moisture imbalance, and then with low vapor pressure excess values of 0.36 kilopascals and very low water activity values. So the data also falls in an area of a warm and dry environment, which is characterized with an impacting score of high humidity being very low. So this means that the environment is dry. And the impact score of having low temperature is also low, which means that it's a warm environment. And then we have a set of recommendations based on these results. And in this property that we just have seen, even though the data is showing a very low moisture imbalance, we always need to look after our property, and to maintain a moisture safe environment, we need to ensure that the performance of the thermal envelope, the provision of ventilation, heating regimes are adequate at all times. By the contrary, we have this property, which is a quite dramatic case of a property with mold. So we have there is no insulation in the roof or a lack of insulation, and there is a ventilation, a PIV unit, which never has been used. So there is any kind of forced ventilation. So in this property, a semi-detached house, which, the ceiling of one of the rooms is totally affected by surface condensation and mold, is showing a very high moisture imbalance with a score of 4.8. So the contribution of a poor building envelope thermal performance to moisture imbalance is very high. The contribution to a moisture imbalance of an inadequate heat moisture regimen is high. So the influence of having low indoor air temperature is very low because we have warm air in this case. However, the influence of having high indoor air RH is extremely high, so it's very humid. And then finally, the influence of having an inefficient ventilation in this property to cause moisture imbalance is extremely high, so it's very poor ventilation. If we see in details the assessment of the thermal performance, we can see that the data falls between temperature factor and water activity to assess this. And we can see that the impact score of temperature factor causing moisture imbalance is high, very high, whereas the impact score of water activity causing moisture imbalance is very high, extremely high. You can see this again, and then the results from the average values, and also as a whole, we are considering both. So the temperature factor value of 0.75 can be considered as inappropriate, considering all the data. And it is a problem when in conjunction with water activity values of 0.95, which is extremely high. Then the assessment of ventilation, we can see how the vapor pressure excess is causing an extremely high moisture imbalance in the property, which is characterized by high vapor excess values, actually very high, 0.98 kilopascals, and very high water activity values. And then we can see how the data falls in an environment of a warm and humid environment, where the impact of having high humidities to cause imbalance is very high, and the impact of having low temperatures is low because the environment is warm. It's a warm and a humid environment. And this is an example of a property where we can see that the causal factors that are causing imbalance is the problem is the envelope and the ventilation, lack ventilation and poor envelope, which extremely high impact of moisture imbalance. And then as a whole, we have a total very high imbalance score of 5.2 of the assessment. In this other case, we see that we have a problem with ventilation with extremely high scores causing imbalance. But however, the heating is adequate. But because the envelope is also causing a problem, we have as a whole a high imbalance score of 3.7 in this property. In this other one, we have that even though we have a problem with the envelope, so there is risk of having surface condensation with this envelope, but the surface of this is dry, so the water activity values are low, and this is because the ventilation and the heating are adequate. So as a whole, we have a low moisture imbalance of 2.3 in this property. In this other example, we have that the ventilation is a problem, so with high scores of moisture imbalance. And however, the envelope and the heating are correct. So we have a very low and low respectively. So we have as a whole, a low moisture imbalance of 2.0 in this property. In this house, what we have is a moderate moisture imbalance that is caused by high impact of the envelope, and then moderate ventilation and heating, which is a property that we need to look after because any changes on the causal factors like a lack of ventilation or a cool environment, air temperatures can increase the imbalance score. So we need to check how to improve these causal factors. And this is another example. We have a moderate moisture imbalance where ventilation is not a problem at all. However, the envelope, even though the thermal efficiency is, it seems right, however, the surface of the envelope is very humid. So we have high values of water activity. And then this is caused. The heating is inadequate since the environment is really cold and very humid. So as a whole, we have a moderate moisture imbalance, which needs to take a look at this. And this is an example of a property with mold and condensation problems before changing the ventilation system from ventilation system 1, an extraction fan, intermittent extraction fan, to ventilation, mechanical ventilation, continuously running and with humidistat. So we can see how the data goes from a very high moisture imbalance, 4.5, and changing the ventilation, we correct the environment, and this goes to a low moisture imbalance of 2.2. So we can see the difference before, how the data falls in an area with risk of mold growth and trapped moisture from a poor ventilation. And then we can see the difference, like how the data moves to an area that is safe of mold growth and not trapped because the ventilation has been corrected. So just to remark which are the benefits of the mildew diagnosis, although I've already explained some of the benefits of this, just to summarize how the BMI moisture diagnosis can be useful for building surveyors and other professionals. Well, it provides a standard, accurate, fast, and reliable way to interpret environmental data. It gives an impartial technical evidence of moisture imbalance. It also indicates which is the problem causing moisture imbalance, and it helps to identify what solutions are required to reduce condensation. And then, as I said, it generates autonomous summary technical reports with interpretation of results, recommendations, and explanations of the method. But why this moisture diagnosis is useful for surveyors? Well, it can help surveyors to quantify and rectify atmospheric moisture imbalance and surface condensation and mold growth in buildings. It indicates measures for different potential solutions that can be required in retrofitting projects that can avoid inaccurate and expensive interventions. And it provides a neutral assessment to support householders and landlords for solving and saving costs from these repair claims. And then, as I said, it delivers professional technical documents, which can save loads of time and money by processing the data and interpreting the data. And also, it provides objective summary reports. And how the diagnosis, the BMI diagnosis, can be applied in a retrofitting project? Well, it can be applied before starting the works to assess the moisture imbalance, and then after finishing the works to check if the intended outcomes have been realized. And as part of a retrofit design and assessment during monitoring and evaluation of retrofitting works that comply with PAS 2035, the BMI diagnosis may support the retrofitting designer and assessor by the provision of environmental assessment, as I said, before and after the execution of the works, so pre and after the energy efficiency measures are applied. And then it can support as well the monitoring and evaluation process by assessing if the intended outcomes, like for example, elimination of damp and mold, have been achieved, or it can help to identify if any unintended consequences have been raised from after the retrofitting projects, like generation of moisture. And then, which are the benefits of using the BMI tool for householders and landlords that are performing retrofitting works? Well, it provides evidence of high quality retrofitting projects by assessing the environment before and after, pre and post installation of the energy efficiency measures. And then it delivers high quality design, assessment, monitoring and evaluation. So therefore, better retrofitting design plans and assessment reports. It can support, as I said, to avoid unintended unexpected consequences of the retrofitting works, generation of moisture. And it drives to best decision making by helping to find efficient and cost-effective solutions from the provided recommendations and assessment. And finally, but not for that less important, it helps to ensure the achievement of better indoor air quality and healthier moisture balanced living environments. So thank you very much for listening. Hope you find this useful and interesting. And please, if you have any questions or if you need additional information, just contact me with the details that are below. And yes, and I'll be there to answer all your queries. Thank you very much.